Hello, my name is Mr. Wyrick. I'm here to talk to you today about lesson 10.7, special segments from a circle. This is going to be one of the more complex things that we talk about in this chapter, which is why it's all the way near the end. There's a bunch of different special segments. First off, chord segments. And there's a longer definition in the book that you may want to take down, but basically what it is we have divided chords. Not necessarily a diameter, just talking about different chords within the circle, and they cross each other at some point, making chord segments. I have here labeled just like it is in the book, and then theorem 1015 goes right along with this. The products of chord segments are equal, and it's for the individual chord is where you have to find those chord segments. So no matter what's going on with this, it's already been proven, so you don't have to go back, do proofs on anything like that. If you have a chord like here, the product of this portion of the chord, AB, this little part times the bigger part, BC, will be equal to this portion of this chord, this DB, and then BE. So whatever's going on, however they're divided, take the ones that are in a straight line, both of those segments, multiply them by each other, and then the straight line of that other one, those two segments will multiply by one another, and the products of those, the outcome of multiplying them, should be equal. If it's not, then it's not a circle. And if it is the same, or if you need to calculate right to make it come up the same, make sure you're doing that properly. The next one that you talk about is a secant segment. If you remember, the secants go all the way through to the outside of the circle. If you have a secant segment, it's part of a secant. It has one endpoint on the circle. Now this can be confusing because AC, what appears to be like the entire secant, is a secant segment, and then AB, where it goes from the outside and just touches the circle, that is also a secant segment. So to differentiate between the way that they look, AB, AD, these two here like this, that just go out and touch the circle, those are called external secant segments. They occur entirely on the outside of the circle. And then we have AC and AE. Those are secant segments, but they're part outside, part inside. Now we don't include the D in that. We just say we're going straight from A to E. We don't include the B here. We say we're going straight from A to C, which leads us to 1016. If we have 1016, the product of a secant times its external segment. So we have this secant segment here, AC, and we multiply it by the external segment, which is AB, will be equal to our secant that intersects it. This is, of course, if there's an intersection, which would be this ADE one here, times its external segment. So it's AB, the external segment, times the whole thing starting over at A, which would be AC. AB times AC is equal to AD, the shorter segment, times AE, the whole thing starting over again at A. So make sure you take stuff down on this, make sure you have picture representations, make sure you get it in your notes very well, because that's tricky to have to start back over. It's not the same as these chord segments where it happens inside the circle. We take where it's divided, the smaller part, or the external part, not really the smaller. Smaller on my representation here, but not necessarily smaller in one that you might find. This external segment times from the intersection point to the outside of that circle, and then this external segment times from that intersection to outside that circle. Okay, those are going to multiply together. The last one that we're going to talk about is a tangent segment. If we have a tangent segment, it's the segment of a tangent with an endpoint on the circle. Basically, what you've been thinking of as a tangent this entire time, we can call that same thing a tangent segment. So it'd be like JK here, from where it intersects out here to where it touches the circle. And if we have a tangent segment that intersects a secant, in this case, it's not going to be tangent with tangent. We had chord with chord, we had secant with secant, but we're going to have tangent with secant. Okay? If that tangent segment intersects that secant segment, it's going to be just like we had over here on 1016 for the secant. This JL, the external segment, times JM from the intersection to the other side of the circle. That's what we'll do with the secant. And that product is going to be equal to our tangent segment, this JK, squared. Okay? So if you can remember how the secant is supposed to be split up for 1016, then it will be split up the same way for 1017. So there's a little bit of similarity there that you can deal with. You can work with that. If there's something that you don't understand from this, you take a peek at the problems, you know, and you're like, I don't get this, I don't know what's going on here. Make sure to raise your hand during class, ask me before class, show up to tutorials, whatever it is you need to do. Make sure you ask those questions, get that understanding. For today, I'm going to write this up here. Apologies, we will do numbers 6 through, we'll say 28. Okay, so problems 6 through 28. Go ahead and work through those once you get to class, and we'll see you then.